NaCl dissociates to make chlorine and nitric oxide. It's a gas. Okay, the delta H value for the reaction is positive 76 kilojoules per mole. Okay. So if our forward reaction is exothermic, then the back reaction is endothermic. The same applies in reverse. If the forward reaction is endothermic, then the back reaction is exothermic. So it's interchangeable. Yeah? It's only telling you one, but you can swap those. If forwards is exo, backwards is endo. If forwards is endo, backwards is exo. Yeah? This reaction here, got the breakdown of NOCl, which is nitrosyl chloride. Okay, the forwards reaction gives us a delta H value, so this is the heat energy of positive 76. A couple weeks ago, or last week, we talked about these values here. If they're positive, it means the reaction is something. If they're negative, it means the reaction is something. In terms of exo and endothermic. So you guys remember what positive tells us? Is it endo or exo? Positive. Endo. Good. It means it's gaining energy. Positive. If it's negative, it means it's losing energy. So from here, we can say the forwards reaction is endothermic. So what's that? What is that? What can we then say about this reaction from that information? If the forwards reaction is endothermic,
the back reaction is exothermic.
Okay. The backwards reaction is exothermic. Right. So that's the first two things we need to identify about a chemical reaction if we want to discuss the effects of temperature when it's at equilibrium. That's step number one. Figuring out if the forwards reaction is endo or exo, and then from that, whether your backwards reaction is endo or exo. It's very simple. We just look at the sign of our delta H value. Okay. Le Chatelier, he states that if the temperature of a system is increased, the equilibrium shifts in the direction that absorbs the heat energy gained from the surroundings. Okay, so if temperature is increased, equilibrium shifts towards the side or in the direction of that is going to cause heat energy to be gained from the surroundings. So heat energy gained from the surroundings, is that endo or exo? Gaining heat energy. Gaining heat energy is endo.
It's taking it.
Yeah. So if temperature is increased, equilibrium is going to shift in the direction that where we've got a gain of heat from surroundings. So is that going to favour the forwards or the backwards reaction?
It'll favour the forwards reaction.
Favour the forwards reaction. So a takeaway message is if we increase temperature, we favour the endothermic reaction. Okay? Increasing temperature favours endothermic reaction. At equilibrium. Okay? So, from that information, if I was to say what would decreasing temperature favour? Come on, Brenda. If increasing temperature favours the endothermic reaction, decreasing temperature favours the exo. Right, easy, good, simple as that. what we should be noticing is that all of these changes, if one thing works one way, then the other thing is going to work in the opposite way. It's the good thing about equilibrium. If you remember half of the stuff, the other half is very easy to figure out. Very important. Increasing temperature favours endothermic reaction, decreasing temperature favours exothermic reaction. Okay, so we've got a little table here. So if the temperature is decreased, equilibrium shifts in the direction that releases heat, so it shifts towards the exothermic direction. So increase, equilibrium shifts towards or to favour the endothermic. Decrease, equilibrium shifts for exothermic. So that there and that is just what I've written in this box.